Then we have the open oceanic province. These are the deep ocean areas and the shallow water above the deep ocean. This covers a large part of the globe. It's our largest province overall. Down in the deep ocean, temperatures are consistently cold. Okay, yeah, you do have little tiny hot springs here and there, but for the deep ocean as a whole, that's not a big part of it. High pressure, dark. Now, of course, up at the surface, things can be warmer if you're close to the equator, and you're under less pressure. There's less water on top of you. In deep water, again, most of the food is from stuff sinking down. This is referred to as marine snow, the bits and pieces of dead stuff and waste and whatnot that is sinking down from the shallow water where you have photosynthesis. So aphotic, not light. We can have filter feeders, though there's less and less plankton as we get deeper down, so that becomes less practical. Of course, in the shallow water where there's enough light, we do have phytoplankton, algae and bacteria that are able to photosynthesize. And of course, we have the various options of predation and scavenging on things that have sunk down or the life in that region. We have a variety of fishes and invertebrates. Some air-breathing animals are able to dive down into these depths, but they obviously don't stay there permanently. In the deeper water, there are all sorts of special adaptations dealing with the dark and limited food supply. Some are able to produce light and use this, whether it is to help find each other, maybe to attract prey, to startle predators. There are several possibilities. One example, as light goes through water, red light gets absorbed relatively quickly. Blue is what's able to penetrate deepest into clear water. This is why pictures under the ocean, things tend to look blue, or if you're snorkeling or diving, things look kind of bluish. That's most of the light that's there. So, as you get into the more twilight zone, basically all the sunshine that's left is towards the blue end. And so, things have eyes sensitive to the blue light. There's one type of fish that's able to produce red light and can see that light as well. So it's kind of got the equivalent of night vision goggles. It can shine its light around and spot other fish that don't see it. Another option, producing light. If you're being attacked, suddenly lighting up may draw the attention of a bigger predator to chase the thing that's trying to eat you. So there are many different ways this might be used. Some animals that manage to get enough food to get quite big in these areas. The giant squid, our heaviest living invertebrate. Well, the colossal squid, there are a couple different types of huge squid that get to large sizes in here. And there are some very long skinny worms that get longer, but definitely not as heavy. Several different specializations. If you are very rarely encountering food, you want to be ready to eat whatever you can find. And so a lot of the fish are able to gulp down a huge meal, potentially even something bigger than themselves, really. This is not just in the deep ocean. There are a variety of organisms that are able to get a huge meal and then not eat for a long time. A lot of reptiles and amphibians do this, as well as various fish. Now, for us, it doesn't work. We're warm-blooded endotherms, so we're using lots of energy from our food just to maintain our body temperature. And we get hungry pretty often. The feeding approach of, say, a number of types of snakes and lizards or these deep-sea fish would be more like if you could totally stuff yourself at Thanksgiving by eating a couple of whole turkeys and then not eating again until you get a couple more turkeys at Christmas. That schedule does not work for us. We cannot eat that much at once, and we get hungry way before the next month. But for animals with the adaptations to handle it, we see that. Gulper eel, classic example there. Here it is. It's a little tricky to see in there. Let me see if still can't really see very well, but the body is relatively skinny, and it's got this huge mouth in front. So it's able to gulp in a relatively large fish and then hang out for a long time just digesting it. Also, things tend to not be very active. There's no sense in just rushing around when you're not going to find much easily anyway. And so there's a lot more of just kind of hang out, and then food happens to come by, gulp it in. Another challenge is, how do you meet folks down here? A lot of space, not a huge number of individuals, and so finding a mate can be rather challenging. So this is where we see the unusual phenomenon with the deep sea anglerfish. A baby male deep sea anglerfish looks like a reasonably normal little baby fish, but once it's able to actively swim, it searches around to find a female, and when he does, he'll latch onto the side and basically just become an appendage for fertilizing her eggs. And so the female is much bigger than the male, almost like a parasite attached on. Although we live on land, we have major impact on ocean areas. Building structures, other development along the coast. We tend to cut down the mangrove forest, fill in the salt marshes, things like that. And obviously it's not good for the habitat if you cut it down and turn into parking lots and resorts and whatnot. We also have pollution, whether it washes down the rivers or air pollution washed down by rain into the ocean. We also have stuff that's dumped by ships or other direct dumping of trash into the ocean. For example, several counties in South Florida have been fighting rules saying that they need to stop dumping sewage just straight into the ocean by 2025. What's that saying about running around on a beach in Miami? A little publicity to tourism might help them change their mind. Sewage can cause disease for ocean creatures, and if they're not killed by it, if we eat them, we can be killed by it. So there are problems there. Many sorts of pollution, some you might not think much about. For example, at least while you were coming to class here, all of you were wearing clothes, and that's a good thing. What you're doing, watching this online, well, don't need to tell me what that might be. But at any rate, that's a good thing. And also, you wash them from time to time. That's also good. But in washing clothes, the little tiny bits of lint are getting washed away, going down, getting into the rivers, washing the ocean. Those tiny scraps of basically plastic for artificial fibers, in turn, is a noticeable component of the plastic pollution that's a major problem for ocean areas. Plastic, for one thing, it can carry toxins, endocrine disrupting chemicals, things like that. Also, little tiny specks of plastic are potentially similar in size to little bits of plankton, things like that. Stuff eats them. A tummy full of plastic may feel full, but it's not giving you any nutrition. So a number of problems associated with plastic pollution in the oceans and other places too. trash, whether washed down from the land, blown in the air, or directly dumped in the ocean. Say, release a balloon, floats in the air, eventually comes down, lands in the ocean, pollution, extra fertilizers, pesticides, industrial chemicals, mining and drilling in the ocean, fishing, dredge net that digs up the bottom of the ocean. All these have major impacts. Besides our big zones of the Earth or smaller local ecosystems, the transition zones can be important. These are referred to as ecotones, meeting of two different environments. You often get distinct diversity, different types of things there, maybe more diversity than either side. Again, different organisms, different size, different perceptions. To a small organism, that ecotone itself may constitute a distinct habitat, a different ecosystem than either side. Here's an example for areas of different soil types from, looks like probably California. Ordinary rocks versus serpentine. Serpentine, again, is a distinctive type of rock that is noticeably deficient in some important minerals, and so only certain types of plants will grow there. Now we see some of them, they don't care where they grow. But we have several here that do not like the serpentine, aren't growing there. And some that like the serpentine, only found there. And we have a few that are just being found near the border. So this transition zone has more different species than is found at either side, in this case for the different plant types.